Section 9.3 is applications and probability. So we're going to look at a couple of different applications specifically in this section. One, I'm sure you've heard before, though you may not know the definition for it. The other one, you might not have heard it expressed in these words before, but you've experienced the idea of it for sure. So the first one, the one that I know you've seen before, is odds. So using that word odds, the odds that something are going to happen, where have you seen the phrases of odds used just in everyday life? What? There's a game called What Are the Odds? Okay, fabulous. What's that? The game is?
Because if you lose, you have to do something bad sometimes.
Oh.
Like you say,
I don't know that I want to learn this game.
jump in the pond, like.
This sounds like truth or dare. We shouldn't play this game. No.
You have to say the same number as the person. So it's like, what are the odds between 1 and 10 that you'll go jump in the pond? And then at the same time you have to say 3, 2, 1, 4. Yeah, like you both say a number at the same time.
What? Oh my goodness. Okay. We're not playing the game. Another example of odds that you've seen. Where have you seen them used besides this interesting game?
The Hunger Games.
Hunger Games, that's what usually somebody tells me these days. That's right, right? The odds are ever in your favor. Yeah. Okay, so Hunger Games. What else?
The lottery.
The lottery. You see that proponent a lot with the lottery. We'll do a lottery question. I don't know if it's in this section or the next one, but we're going to do a lottery question at some point. I don't know if you've been around enough, but odds are what you see used prevalently in horse racing. They always report odds like they do with the lottery. There was another one that I was thinking. Oh, you see it a lot with sports. When there's games, and they'll talk about the odds of one team winning or the other team winning, and they come up with, those kinds of things. Well, odds are actually very related to probability, but they are not the same thing. And oftentimes out in the regular world, people use them interchangeably. They say, what are the odds? And then they're actually talking about a probability. So that actually happens pretty frequently. Odds are actually a comparison of things in favor, like ways that you win, versus things that are against or ways that you lose. So it's a ratio or a comparison. So when we talk about the odds that are in favor of something happening, what you'll notice here is some notation. I believe we've spoken about it, but not at length. Do you see on this one where there's a little line, a tiny little line above the A? It's the complement. It means the probability something won't happen. So odds is actually the probability something will happen compared to the probability something won't happen. So when we were looking at the probability, in the last section we were looking at the probability that you'd have a boy when you had a baby. It's a 50-50 chance, right? So you would say there's a 0.5 probability. But what that means is there's a 0.5 probability that you do, and there's a 0.5 probability you don't. So if you were comparing those, the odds are 1-to-1. That's how that's expressed. In favor, and then against that. So there's also that are called odds against. So odds against just switches the fraction, flips it. So you have the odds against happening, or the probability against happening on top, and the probability for it happening on bottom. So still a comparison, it's just a flip of the fraction. So we're going to do a really simple example with marbles to give an idea of how this works. So we have a set of 8 marbles, 5 red, 3 white, and we're going to choose one at random. It wants to know the probability that you will choose a red. So it said probability. The probability that you choose a red. Well, how many reds are there? 5. How many total marbles are there? 8, right? Okay, so it's a 5 out of 8 probability. But if you wanted the odds of choosing red, what you would be counting instead is the number of reds compared to the number of non-reds, in this case white. So this would be a 5-to-3 or 5-to-3 odds. We can also look at odds in terms of like rain chances. Okay, so we see probabilities a lot of times on weather apps and things like that, but you can look at odds as well, and you'll sometimes see the weathermen talking about it that way. So if the probability of rain for the day is 60%, what are the odds against it raining? So we're looking at odds, and we're looking at the odds of no rain. right? That's really what it says. So the odds that there's no rain would be the probability of no rain compared to the probability that there is rain. And you were given one of those. Which one were you given? The probability of the rain. It was 60%. Now you can actually write it in as 60% if you like. If you want to change it to a decimal point 6, that's fine too. So if there's a 60% chance it rains, what's the percent chance it doesn't? 40. And this is why you can actually express it as percentages if you like, is because it's going to all cancel and reduce out anyway. So 40 out of 60, obviously the percentages cancel, even the zeros cancel. So I have a 4 out of 6 or a 2 to 3 odds. Obviously, there's a relationship or a factor. There's a relationship between these two values, odds and probability. So Theorem 9.8 kind of talks about that, how these two relate to one another. If the odds in favor of the event are m to n, then the probability is m to m plus n. And if the odds against the event are event E are m to n, then the probability is n over m plus n. So if you think about the way this is structured, what this means is the m is the number of ways it happens. We'll call them wins, right? It's the favorable outcome. And the n is the number of ways that you lose, the non-favorable outcome. You don't have to actually be playing a game, but it's the non-favorable outcome. So if you compare this, then if you added these together, you'd get the total number of times you play, or wins plus losses, right? So down here in your comparison, that's why you're getting the m plus n in the bottom. It's the total wins plus losses, the total number of times you played the game or did the experiment, counted the objects you have, whatever. The only thing that's different on the second one is that the n is on top, because you're actually here talking about the comparison of losing. It's the probability of losing the event, okay, or it's a losing outcome. Okay, I think that's probably a good place for us to stop, so we'll pause right there.